Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your paleontology teacher, Jen, and today it's time for some Monday musings. During the late Cretaceous period, North America was split in half by the Western Interior Seaway. The western continent was Laramidia, and the eastern continent was Appalachia or Appalachia, whatever you want to call it from wherever you are. Laramidia extended from the southern parts of Alaska to northern Mexico. The eastern edge was New Mexico, the westernmost edge of Colorado, the western half of Wyoming, Montana, and Alberta, while the eastern edge was Arizona, northeast Nevada, and eastern Oregon, Washington, and British Columbia. It was not a very wide stretch of land, but it was big enough to support a wide variety of dinosaurs. Many of the famous dinosaur-bearing formations were deposited on this continent, including the Prince Creek Formation of Alaska, with all of our Arctic dinosaurs, the Dinosaur Park Formation, and the Oldman Formation of Alberta, the Judith River Formation, and the Two Medicine Formation of Montana, the Kaiparowitz, and the Wall-Weep formations of Utah, the Kirtland and Fruitland formations of New Mexico, the Aguja formation of Texas, and the Cerro del Pueblo formation of Mexico. Did you happen to notice the similarities between the fauna that were depicted in each of these artists' renditions of these different formations? Excellent. You should. The dinosaurs that lived on Laramidia consisted of hadrosaurian ornithopods, or duckbill dinosaurs, ceratopsians, or horned dinosaurs, ankylosaurs, the armored dinosaurs, titanosaurian sauropods, so our big, heavy sauropods, long necks, ornithomimids, our bird-mimic dinosaurs, like that one. Troodontids, which are related to dromaeosaurs or raptors. They're not raptors. If you want more on that, I'll do a video. Dromaeosaurs, so our raptor dinosaurs. Oviraptorids, so our egg thieves. We can also talk about why they're not actually egg thieves in another video. Avialans, which are our closest relatives to birds, and tyrannosaurs, which I don't think I have to explain. They lived alongside turtles, champsosaurs, which kind of look like crocodiles, but they're not crocodiles. They're related, but different. Lizards, gastropods, those are your snails, bivalves like clams, pterosaurs, crocodilians, amphibians, plesiosaurs, which are your long-necked marine reptiles, fish, and probably a lot more that we just haven't found because not everything fossilizes. Now, Laramidia went through some pretty intense mountain building during the late Cretaceous. The west coast was being crumpled under compressive forces as the Kula plate, so this blue one over here, and the Farallon plate, the yellow one down here, were subducting beneath the North American plate, the one I'm currently sitting on. Both in this picture and currently in my bedroom, because I live on the North American plate. Anyway, nerd. Most hypotheses propose that oceanic crust was undergoing flat slab subduction. What the heck does that mean? Now, typically, when we're talking about subduction, we're talking about steep subduction. Our oceanic lithosphere is subducting at a steep angle beneath our continental lithosphere. And that causes active volcanism, as it's because of the angle it's at, the melting's happening right there, so you're getting that magnetism. Now, flat slab subduction is shallow subduction. Shallow angle So instead of dipping like this, we're dipping like this. Now this picture kind of depicts it, making a little wave thing. Possible. Or it's just, this instead of this. Make sense? Whatever it looks like in reality, just know it's a shallow angle. As a consequence, no magmatism occurred in the central west of the continent, and the underlying oceanic lithosphere actually caused drag on the root of the overlying continental lithosphere. So, friction. There's a lot of friction built up. It's not moving very fast. It's getting stuck. One cause for shallow subduction could have been an increased rate of plate convergence. So the plates are it's sinking pretty fast. Of course, if you're causing a lot of drag, I'm not sure how that affects everything. Physics was not my strong point, so if a physicist or a geophysicist, even better, wants to jump in and correct that, go for it, because physics. But another one, another proposed hypothesis was that, English. Okay. All right, we're going to try that again. Another proposed cause was subduction of thickened oceanic crust. So one result of a shallow angle of subduction and the drag that it caused was a broad belt of mountains, some of which were the progenitors of the Rocky Mountains that we know today. Now, part of the Proto-Rocky Mountains would later be modified. They would be modified by extension to become the Basin and Range Province. So just to give you an idea of what that means, when I say Basin and Range, which covers mostly Nevada, but does get some of Utah and I think it's just really those. I think there's a little bit in New Mexico and Arizona, but not a ton. It's mostly Utah and Nevada. But anyway, basically what you have is faulting, as you can see here, and it drops a block, fills in with sediment, drops a block, fills in with sediment, drops a block, fills in with sediment. And so you'll get basins where it's flat, you find people maybe ranching or farming in, there's water down there. Then you have your ranges, so you have little mountain ranges. And if you look at a map, like a topographic map of the United States, you can see the woo going across the map. Here we go. Here's a map, so you can kind of see. It goes a little bit into Oregon and a little bit into California, but not New Mexico or Arizona by the look of it. So, Oregon, California, Nevada, Utah. Anyway, as you look at this, you can see, like, the shadowed areas where all the basins are, and then the high relief of the ridges. So, there's that. Well, thanks for coming to this lesson and enduring my struggles with English today. I was on a plane yesterday, so I mean, my brain is shot. Anyway, make sure you tune in tomorrow for some fun trivia, and I will fossilize you later. Hey, make sure you check out my new Etsy shop, Minerals, Rocks, Fossils, and get some fun merch that'll help me build this channel more. Again, thanks for tuning in, and see you tomorrow. Fossilize you later.